Today I've got an OpVault demo for you, and before that we're going to spend like 90 seconds talking about what OpVault is, just as a refresher. So OpVault is a way of bringing reactive security to Bitcoin custody. And what I mean by that is today, if you set up some keys and deposit some coins, you just sort of hope that you did it the right way and that your hardware devices aren't backdoored, or no one can get to your keys, and you just kind of hope. With reactive security, you can encumber your coins in such a way that if there is key theft, you actually have some shot at recovering the coins. So I like to say it gives you multi-sig safety with single-sig operational complexity at the cost of having to wait a little bit. So the idea with vaults, and specifically with OpVault in particular, is that when you vaulted some coins, there are only two paths that it can travel. It can either be recovered to a pre-configured address, which is presumably a key that you've generated, in a really kind of paranoid way, or it can be triggered, which is where you declare publicly, hey, I want to unvault these coins to a particular address, and then you have to wait some time period for the trigger to actually mature. Then you can do your final withdrawal transaction. But at any point before then, the coins can be recovered. So if you see an unexpected trigger transaction, you can intervene. So when you're setting up your vault, there are a few pieces of data that are important here. Obviously, you want to pick a recovery key that's not correlated to your trigger key in case your trigger key is compromised. But your trigger key could be whatever you're using today to spend your Bitcoin. And actually, you can maybe even be a little bit less paranoid with your everyday spending key because you have the opportunity to actually intervene and recover the keys. Then finally, there's this recovery authorization key, which is a little bit more subtle, but basically that doesn't need to be as secure as either the recovery key or the trigger key. The idea is that when you recover vaulted coins, the only authorization for that is that you're spending those coins to some address, the recovery address. But if a passive attacker is looking at the mempool, sees your recovery transaction, if there was no other authorization, then they could rebundle the transaction to have a really low fee rate and try and pin you. So that's why we have this recovery authorization key, which is optional, but I recommend using. And that's typically just a short passphrase, as you'll see in the demo. So let's actually get into the demo now. Let's assume that you've cloned the OpVault demo repository and you've set up your 3 panes here. So what we're going to do first is source this alias file that's included in the repo. That's just going to set up some shortcuts. It's going to print out some instructions for you because there's a little bit of setup involved here, and I use Docker to try and remove some of the complexity for people who want to reproduce this, but it's still pretty complicated, so we have some aliases. So we're going to build our containers, and there's a little shortcut for that here. And the reason that we're using a container for the Bitcoin instance that we're going to start here is because we're using Bitcoin Inquisition, which is a fork on Signet that's activated CTV and APO, and I have my Vault branch. So we're actually going to be running that here. So once we've got our Bitcoin instance running, we're going to actually create the Vault configuration. So we're going to use this demo command to run these Python scripts within the container. So we're going to create our config here. And you can see that we wrote a Vault configuration to config.json and some secrets to secrets.json. So let's see what's actually in these things. In config, you can see that we've got a spend delay of 10 blocks. We've got a recovery pub key, recovery auth pub key, and that's, again, generated from a passphrase I'll talk a little bit about later. And we've got our trigger xpub. So the trigger is given as an xpub because for every vault deposit that we're going to do, we're going to actually generate a new trigger address. So we specify an xpub there. And we got some other state that maybe we'll get into later. If we look at that secrets file, in there, we've basically just got the trigger xpriv. Normally, this would live probably on a hardware wallet or something. And then we've got the recovery auth phrase that's actually used to generate the recovery auth key. And the idea here is that, for your recovery auth, because it's not security critical, it's just used to prevent people mucking with your recovery transactions in the mempool, you might just have a short phrase that you've written down somewhere that you enter in, and that'll come into play later. So okay, now let's actually start running the watchtower here. So we're going to do demo main.py, and this boots up the Vault monitoring system. So this is going to do all kinds of stuff, as you'll see shortly here. So the first thing that we want to do is actually add some coins to the fee wallet. Because for our Vault transactions, because of the way that value preservation works, we actually have to use other coins for fee management until transaction V3 comes along. So let's see if we can actually deposit to our fee wallet here. We're going to create a wallet called fees. Cool. So that's now active. And we're going to mine 200 blocks to this fee wallet address. Okay, great. So we got some fee coins. Now we're actually going to make a deposit to the vault. So the way that we do this is we take our vault address here. Whoop. And we're going to do Bitcoin CLI send to address, our vault address, and then let's send, I don't know, 10 Bitcoin, 10.1. Oh, yeah, right. I've got to actually fund the wallet. All right, so let's mine some blocks. Wallet is funded. Now let's try that again. Cool. All right, so we've got a transaction sitting in the mempool. We've just got to mine another block. Bingo. So the monitor's detected that we've seen a deposit, and now we've got a new deposit address. So let's just do that again. Why not? To the new address. Okay, mine another block. Bingo, another deposit. Okay, so let's actually see what the withdrawal flow looks like here. So again, we're going to trigger a withdrawal to some destination, and then that withdrawal is going to have to sit there for a few blocks so that, you know, the authorized user can intervene if that were actually necessary. So just for the sake of simplicity, we'll trigger withdrawal to the fee wallet. So what we'll do is main.py, withdraw the address, and let's do 9,001 Satoshis. Okay, cool. So we created our trigger transaction, submitted it to the mempool, and now the monitor has actually seen that come through. So let's mine a block. All right, now at that point, the trigger transaction has actually seen a confirmation. And if we mine another block, we can see that the trigger has 9 confirmations to go. So let's mine 9 more blocks. And we see that the trigger has matured. So now the monitor has actually broadcast the withdrawal transaction to move the funds out of the trigger on their way to the final destination. So let's mine another block. All right, our withdrawal has been completed. Cool. So now let's see what it looks like if our coins were actually stolen and we wanted to intervene. So what I'm going to do here is use this command called steal. And steal essentially does the same thing, but it doesn't make the monitor aware of the trigger transaction. So the monitor gets surprised, as we'll see in a second here. All right. So now we've got to mine another block. And uh-oh. You can see here that the monitor is freaking out a little bit because it's seen a trigger transaction confirmed that we didn't submit, and it doesn't recognize. So let's actually go ahead and recover those coins. So we'll run main.py recover. It's going to tell us which vaulted coins we're actually recovering. And it's going to ask us for the recovery phrase just so I can do that signature so that nobody can muck with our recovery transaction. I think in this case, the recovery phrase is change me to. So I'll enter that in. It'll generate the key, sign the recovery transaction, and it's submitted it to the mempool. So let's mine the blocks. Cool. All right. So what it did there is it actually swept our coins that were at risk out of this trigger transaction that an attacker had created into our recovery address. So that was just a quick demo showing off the full op vault workflow. I hope you've enjoyed it.